Imagine this. You've just come up with a brilliant idea, a gadget, a replacement part, or maybe even something that could become the next big product on the market. The possibilities are exciting, but before you get too far ahead, there's a crucial question you need to answer. What is your idea actually made of? Is it lighter, cheaper, or stronger? This is the first fork in the road for every inventor and designer. The choice between plastics and metals is a classic showdown, and it's not always as simple as it seems. Each material brings its own set of strengths and weaknesses to the table, and your decision will impact every aspect of your product. Your material choice shapes everything: manufacturing process, cost, weight, feel, durability, and even how your product is perceived by customers. Get it right, and you're set up for success. Get it wrong, and you could face costly failures, recalls, or unhappy users. In this video, we'll break down how to choose the right material for your project, step by step. There's no single best material, just the right one for your specific job, your goals, and your constraints. Plastics offer incredible design freedom, lightness, and cost savings at scale. Think electronics housings, car dashboards, or even toys and appliances. Metals, on the other hand, win on strength, stiffness, and heat resistance, making them perfect for heavy loads, moving parts, or extreme environments. We'll build a practical decision-making framework, covering function, forces, environment, looks, and production volume, so you can make an informed choice. By the end, you'll have the knowledge to decide if your idea should be plastic, metal, or maybe even a clever combination of both. Let's dive in and get started. Let's get practical. When it comes to choosing the right material for your part, a clear, step-by-step approach can make all the difference. Start by defining your part's job in a single, focused sentence. What is its main purpose? Is your part holding something in place, acting as a handle, or transferring force from one area to another? That's your functional requirement, and it's the foundation for every decision you'll make next. Next, consider the mechanical needs. How much load will your part need to handle? Is it a constant, static load, or will it face dynamic changing forces over time? Metals are generally stronger and stiffer, making them ideal for high-stress applications. Plastics, on the other hand, are great at absorbing impact and can flex without breaking. Geometry matters too. Plastics really shine when you need complex shapes or integrated features. Think snap fits, living hinges, or parts with intricate details that would be difficult or expensive to make from metal. Parts consolidation is another big advantage. You can often replace several metal pieces with a single molded plastic part, which saves both assembly time and overall cost. For simple, straightforward shapes, metal might be the best choice, but for complex shells or enclosures, plastics usually come out on top. Don't forget aesthetics. If you need color or texture, plastics can be molded in a wide range of finishes, saving you extra painting or finishing steps. Metals, by contrast, often require painting or special coatings for both appearance and corrosion resistance, which can add time and cost. The feel of the material matters too. Metal feels cool and premium in the hand, while plastic is lighter and warmer. Neither is inherently better. They just offer different experiences. Ultimately, you want to match your material choice to your specific needs, balancing function, cost, and user experience. Even this first pass at evaluating your options will help you narrow down the choices. Let's keep going and dig deeper into the details. Now, let's take a closer look at the environment your part will face. The conditions it encounters can determine whether it thrives or fails, so it's crucial to think ahead. Temperature. Most plastics begin to soften or deform when exposed to heat, which can be a problem in high-temperature settings. Metals, on the other hand, generally remain stable and don't flinch under heat. There are high-performance plastics designed to withstand extreme temperatures. But keep in mind, these specialized materials often come with a much higher price tag. Chemical exposure. Some plastics are vulnerable to cracking or degrading when they come into contact with oils, solvents, or harsh chemicals. Metals can also suffer, as they may corrode over time. However, certain metals like stainless steel and aluminum offer excellent resistance to many chemicals, making them a reliable choice in demanding environments. Outdoors. UV light and moisture are relentless enemies of plastics. Prolonged exposure to sunlight can make plastics brittle and prone to cracking, while moisture can cause warping or swelling. Metals, meanwhile, may rust when exposed to the elements, but they don't fade or become brittle like plastics do. Regulations. If your part is intended for medical or food use, you'll need to ensure it meets strict regulatory standards. Some plastics and metals are certified for these applications, but always double-check compatibility and sterilization requirements to avoid costly mistakes. End of life. Is your material recyclable? Both metals and some plastics can be recycled, but the recycling processes and streams are different. Consider how your part will be disposed of or reused at the end of its life to minimize environmental impact. Every environmental factor can make or break your design. Don't skip this critical step. The right material will survive and perform in its intended world, not just look good on paper. Think about the entire life cycle of your product, not just its first use. Carefully answer these questions before you commit to a material. Now, let's talk money. Money talks. Tooling costs are the big divider. Plastic injection molds are expensive, worth it only for high volumes. For small runs, CNC machined metal parts are cheaper up front, but pricier per part. As volume rises, plastics become more economical. Assembly. Plastics allow snap fits and welded joints, fast, cheap, and perfect for automation. Metals need screws, bolts, or welding, strong, but slower and costlier. Always consider total assembly cost, not just part price. Parts consolidation with plastics can slash assembly time and labor. For low volume, metal is often best. For mass production, plastics win. The economics are clear. Match your process to your scale. Next, let's meet some common plastics. Plastic is a huge category, just like metal. ABS, tough, impact-resistant, great for electronics and automotive trim. Polycarbonate, clear, super tough, used for safety glasses and water bottles. Polypropylene, cheap, chemical-resistant, perfect for living hinges and food containers. Nylon, strong, low friction, ideal for gears and bushings, but absorbs moisture. Acrylic, clear, weather-resistant, used for signs and windows. Most plastic parts are made by injection molding, fast and repeatable for high volumes. For prototypes or small runs, 3D printing is flexible and quick. Extrusion makes pipes and profiles. Your manufacturing method depends on material, geometry, and volume. Know your options before you design. The right plastic and process go hand in hand. Now let's avoid common mistakes. Designing plastic like metal is a recipe for failure. Mistake 1. Inconsistent wall thickness causes warping and sink marks. Golden rule: keep wall thickness uniform. Mistake 2. Sharp internal corners invite cracks. Always use generous radii. Mistake 3. Forgetting draft angles. Parts get stuck in the mold. Add a slight taper to every face. Mistake 4. Over-engineering with expensive plastics when smart geometry with cheaper material would work. Use ribs and features to add strength before upgrading material. Good design is about geometry first, material second. Avoid these traps for reliable, cost-effective parts. Let's see this in action. Case 1. Smartphone case. Needs to be light, absorb impact, cheap at scale, colorful, and non-conductive. Mechanical need: impact absorption. Geometry: complex shell. Volume: millions. Aesthetics: critical. Plastic is the only real choice. TPU or PC ABS blends are perfect. Metal would be heavy, expensive, and block signals. Case 2. Cinema camera mounting bracket. Needs extreme strength, rigidity, precise threads, and low volume. Mechanical needs strength and stiffness. Geometry simple. Environment-wide temperature range. Metal, specifically machined aluminum, is the clear winner. Plastic would flex, deform, or fail. The framework makes the right choice obvious. Real-world needs drive material selection. Don't guess, analyze. Now let's wrap up with a checklist. Here's your quick checklist before you choose. Function. What's the part's main job? What loads will it see? Environment. Temperature, UV, chemicals, moisture. Geometry, simple or complex. Can you consolidate parts? Assembly, snap fits or screws. How will it go together? Economics. What's your production volume? What's your budget? Aesthetics. Color, texture, feel. What matters most? Prototyping and regulations. Have you tested it? Any standards to meet? Use this list to guide your decision and avoid costly mistakes. Now go build something great. The right material is your foundation.